Next one is entropy coding. In entropy encoding is a lossless and independent of type of informations that is being compressed. It is concerned slowly how the information is represented. We can take two examples which are widespread use in compression algorithms in order to illustrate the principles involved for that particular algorithm. One is called run length encoding, another one is called as a statistical encoding. What is run length encoding in the sense? Run length encoding is a typical application. In this type of encoding, when the source of informations comprises long substrings of the same character or a binary digit. Here, instead of transmitting the source string in the form of independent code words or bit source string, is transmitted in the form of different sets of code words which indicate the particular character or the bit which is going to be transmitted. So, if the transmitted in the form of different set of code words but also indication of the number of characters or bits, the substring provide the destination to know the set of code words being used as a destination. Simply interprets each code word which is received and the appropriate priority of the number of bits. So here we are going to discuss about the run length coding. For example, an application which involves a transmission of long string of the binary bits which consists of a limited number of substrings. Each substring can be assigned as a separate code word. The total substring or the bit string is then transmitted in the form of a string of code words which is selected from the code word. For example, the application uses this technique for the transmission of binary strings produced by a scanner in a facsimile machine or maybe in the telegraphic machine. In many instances, when scanning the typed document, the scanner produces the long substring. Either the substring consists of zeros and ones of binary number. Instead of transmitting all the binary numbers or all the strings, the code word is converted into zeros and ones. So each indicate the bit of 0 and 1 in the number of bits in the substring. For example, the output of the scanner is 0 0 0 0 0 0 1 1 1 1 1 1 1 1 0 0 0 0 1 1 1. How this could be represented in the sense? How many zeros are present? 7 zeros are present. How many ones are present? 10 ones are present. Again, how many zeros? 5 zeros are present. How many ones are present? 2 ones are present. So this can be represented like 0, 7 indicates 7 zeros, 1, 10 indicates 10 ones, and 0, 5 indicates 5 zeros, 1, 2 indicates 2 ones. So alternatively, only two binary digits, zeros and ones are involved. We ensure that first substring is always comprises of binary 0, then the string could be represented like 7, 10, 5, 2. To send this digital form, the individual decimal digits would be sent in their binary form. So instead of 7, 10, 5, 2, again it will be converted into 0, 1, 1, 1, 0, comma 0, 0, 1, 0, comma 0, 1, 0, 1, comma 0, 0, 1, 0. That is in binary format, this can be sent. So to send this in a digital form, the individual decimal digits would be sent in the binary form, assuming the fixed number of bits per code word of the number of bits per code word would be determined in the largest possible substrings. Next one is a statistical encoding. So in many applications, the set of code words to transmit the source information, for example, set of ASCII codes are often used for the transmission of string of characters. Normally, all the code words in the set comprises fixed number of binary bits. For example, 7 bits in case of ASCII. In many applications, however, the symbols and code words that present in the source information which do not occur with the same frequency of occurrence, that is with equal probability. For example, in a string of text, the character may A, if you talk about the character A, which may occur frequently than P, which will occur more frequently than Z. Likewise, the statistical encoding exploits the property of by using the set of variable length code words with shortest code words used to represent the most frequently occurring symbols. So in practice we are using that variable length code words, which is not quite as straightforward. So the run length coding, the destination must know the set of code words being used by the source. With the variable length code words, in order for the decoding operation, it should be carried correctly. It is necessary to ensure the shorter code words in the set does not form the starter of the longer code word. Otherwise, the decoder will interpret the string in normal code word binary. The code word sets the avoids happening to this the prefix property, and an example of the encoding scheme which generates the code words which have this property. So that kind of algorithm is known as Huffman algorithm. The theoretical minimum average, the number of bits that is required to transmit the particular source stream is known as entropy or entropy of the source, and can be computed using the formula called entropy. H is equal to E summation of minus summation of I is equal to 1 to n pi log base 2 into pi, where n is the number of different symbols in the source stream and pi is the probability of occurrence of the symbol I, and efficiency of the particular encoding scheme is often computed as the ratio of entropy of the source to the average number of bits per code word that is required with the scheme. So average number of code words per average number of bits per code word can be represented as summation I is equal to 1 to n ni into pi. This is the formula, ni into pi. So statistical method and run length encoding method are coming under the entropy coding. Thank you.